Hello, my name is Rainer Hanekamp. I am a trainer and consultant at Angular Architect, and in this video I want to show you why you want to use the Cypress Component test runner instead of the classic testbed based tests. And the way how I'm going to do that is, first of all, we have an introduction, so I will say a little bit why it is so hard currently to test something in Angular. Then I also have prepared an example where I'm writing exactly such a testbed paste test. Then I will rewrite the same test with Cypress, but it will be an end-to-end test, and that will ultimately lead us to the component tests in Cypress, which more or less combines best of both worlds. So, what is it about testing in Angular? Well, first of all, we have to differentiate between three different categories of testing. First one is unit tests, the second one is component tests, and the third one I would define as end-to-end tests. Now, what are the definitions for these types? Unit test is something when you're instantiating the class on your own. Inside of your test, you're calling new class, you'll pass on the dependencies or mocked version of the dependencies, obviously, and you only test the class itself. No DOM interaction, no testbed. Very basic tests. The more interesting ones are, of course, the component tests, because there we have the testbed, there we have the DOM interaction, and there we have some issues. And then the last category are the end-to-end tests. Well, they are very easy to write when you're using Cypress, for example, but they also have some disadvantages that we will discuss later. Now, about the component tests. They are the hard ones. Why are they hard? I would say because of four different reasons. The first one is the configuration of the testing module. Now, the testing module is something that we cannot just eliminate, because we need it, because we need to define which dependencies we want to mock and which ones we don't want to mock. The complexity comes more or less from Angular itself. We need to know about the relationship of components, how services behave, what is it about providing and all that stuff. So this makes it quite complicated. The second reason is asynchrony. In our tests, we have to know at which locations or at which lines of code we are internally triggering asynchronous tasks. Because inside of our tests, we need to manage them. We need to use fake async together with tick, where we say, okay, I know there are now some asynchronous tasks, some were running, run them now synchronously, and then I want to continue. This is something we don't have to do in our application code, it just works. But in tests, we need to manage it. The third reason is DOM interaction. Also something which works fine in the application, but which causes us troubles in our tests. What do I mean by that? Well, it depends on how many components you're using in one particular test. Because some components, they are listening for particular DOM events, and only then, if these DOM events are really dispatched, then they are working properly. You have to know that when you write a test and you're using the real component there. We will see in the example how easily we can get into such a situation. And the fourth reason is the change detection. So this means fixture detect changes. This means we need to manually trigger the change detection, otherwise the HTML or the DOM isn't updated. And again, this is something that this is a problem that we don't have so much in our applications, but in our tests, it's really a thing. And we can, of course, configure Angular or the testing module of Angular that the change detection happens automatically, but nevertheless, there are some cases when even with automatic change detection turned on, that it is still not working. So these four reasons, the testing module, the asynchrony, the DOM interaction and the change detection, they make testing so hard. And many developers say, and I completely understand this, they say, look, I don't have time for this. I have other things to do. It's just too hard. And then they go on and say, okay, we mainly focus on end-to-end testing. We know it's not perfect, but at least we have some coverage or some tests in place. Or even worse, which is of course something we want to avoid, they don't test at all. Okay, and now let's take a look at the code example that I've prepared. Okay, so this is the application that I use more or less all the time. And we have here the holidays overview. And I, as user, I can now select some holiday, for example, Vienna. And I can click on Get a Brochure. And this is now the component we want to test. The way how this component works is that I can enter a kind of address into it. Then I click on Send, and then a request goes out to the OpenStreetMap API. We are validating that there are some addresses which fit this query or this input. And if that's the case, then we say brochure send. If not, then we are getting address not found. And this is what we want to test. Let's take a look at the code. So this is already a standalone component. It's here the request info component. We see that it is standalone because of this property here. So it contains already all its dependencies, and an Angular module isn't required anymore. How does it work? Well, we have here, let's take a look in our template. So when our users click on the button search, in this case, the event handler is triggered, and the name of it is search. So what's happening here, it's not extremely simple, but still understandable. So the submitter is a subject which is emitting a next, and we see here that there is an observable which is waiting for the submitter to emit the submit event, and then it takes from our form group the input value, passes it on to a service, which is in this case the lookup service, and this lookup service returns a false or a true depending if this address does exist or not. And of course, to make it a little bit challenging, we have here asynchrony in place. There is a delay, and in the end the boolean gets transformed into a string, which is what our users will see in the end. Let's take a look at the address lookup. The address lookup isn't doing that much again. It's very simple. We see here our HTTP request to the OpenStreetMap API. But before this service actually requests or is sending the request, it's parsing the address. You could also say it is validating the address. So there is a function where we have regular expressions and we say, yes, it looks kind of an address. So it's safe for us to go to the API and do a remote check, so to say. So we can say that in order to fulfill this feature, we have three different elements. We have our request info component, the component itself. We have the address lookup and the service, and we have a parse address, which is a simple function. And what I want to do now is that I want to write a classic test where I test all of these three elements together. And of course I will do this via the DOM itself. So I will not call directly any of the methods of these classes. I will really interact with the component as a normal user would do. So normally when we are using the Angular CLI, we have already a spec file available. I created because I removed it, and I want to show it from scratch. So this would be request info component spec.ts, and I will only write one test. So I would say it should test request info. The first thing that we have to do, of course, is to configure the testing module. So I say test module, configure testbed, configure testing module like this. And then normally what we see is that we have the declarations where we are defining the component that we want to test most of the time. And then of course it comes to the imports where we need to provide the dependencies for the components. And here we have to ask ourselves, what do we want to mock? What do we don't want to mock? And in my case, I say I don't want to mock anything except the HTTP request, but I want to include everything as it is. Now, what are the dependencies of this component? Well, it's actually these 7 modules in that case, or also standalone pipes or directives. And I would have to copy them. So I would have to say, yes, I want to copy them into the imports. And then, of course, if that is done, the next question is about the providers when it comes to the services. So I can now say I want to mock a particular service, or I don't want to mock them. As I said before, I don't want to mock them. I only want to mock the HTTP request, but everything should just stay as it is in the application. So I'm going to remove that one. Because I want to mock the HTTP client, that's what I want to do. Obviously, I am using the official or the Angular testing module for the HTTP client. So this is the HTTP client testing module. Of course, I am also using here Angular material. Normally we have the browser animations module in our app module. I don't want to have the animations here, but I need to provide some kind of animations module. That's why I have to use here the Noob animations module. So this is what you have to know. You really have to know what kind of dependencies does your component have and which ones do you want to mock. Now, in our case, it's a little bit easier because first of all, I use your standalone component. And when I say, well, with a standalone component, the declaration is already done by this component more or less itself. And also all these all these dependencies, they are also included already. The only thing, or I can shorten it by just saying I want to import the request info component and I replace it with all the dependencies coming from my component directly. And I also don't need to declare anything because again, this is a standalone component. It acts both as a component but also a module, so the declaration is already also done here. Much easier. Of course, if I would say I don't want to use the original dependencies, it would look a little bit different. I would have to write more in that configuration here. But for now, that's fine. And now I say I want to create the component. I store this on the fixture. And of course, I want to create the request info component, that one. Okay. First thing we always have to do, we need to call detect changes. Detect changes will make sure that all the directives are more or less executed so that everything, the template works as it should. And of course, the ng on init is executed. Also, the ng on changes when some input values are set. This is something we require. And then we need to fetch the input element because this is where I want to type something in. And the normal way or the standard way how we do this is that we again go to our fixture. We say, dear fixture, fetch me or query via the debug element via a CSS selector. I want to have the input field. Now what I use in this case is as a selecting strategy. I'm going with the data test ID approach, so I will not use an ID attribute. I will also not go via any CSS classes. I just go via data test ID. It's an attribute which only exists for testing purposes. So I need to say there should be an attribute which contains address like this. I want to get the native element. I want to have the DOM element, and this is of course of HTML input element. Good. Now I have my input element. How can I type something in? Well, we can't. We can set the value. This is what we can. So I say I want to set the value input, and I set it to an address which I know that exists. And the problem now is and this is which I said before, I need to know a little bit about the components or the directives that I'm using. Because if we take a look into the template, there is an input. And I'm using a form control for that. So the reactive forms is powering this form. Now the reactive forms, they don't know that the value property has changed because they are waiting for a DOM event, which is telling them, look, there was a change, you want to synchronize yourself. So you want to fetch the new value from the DOM and store it inside of your form control. The test doesn't dispatch this DOM event, so I have to do this on my own. I have to do this manually. And the way how we do this is that we say dispatch event, we say it's an event of type input, and now the form control is aware of it and will take on the new value. If I miss this line, it will not work. So again, this is something that I have to know because otherwise it's not just working. Okay, so we have entered something. We can say that our form control has the value. The next step is rather easy. We need to fetch the button. For the button, I also have a data test ID. It's a button search. So more or less, I just replace it here, address with a button search. And it's a native element. So I can actually just say click, and that's it. So now I've clicked on it, and now comes the asynchrony, because now I have to know, okay, an HTTP request should be sent out. The address lookup will take care of that. It will return something. And then when the address lookup returns something, we have something else. So we have here a delay. So there is some asynchrony involved. And only then will the observable, the lookup result, get the final value, which is of course the message. Now, how do I do this? So first of all, an HTTP request is involved, and that's why we need to answer that one. I'm using the HTTP client testing module. That's why I say testbed inject. We have the controller available. This is the testing controller. Where is it? Here. And with the testing controller, we can say, look, there should be an acute request, so there should be a request somewhere. And what I want to have, I mean, if there are multiple requests, I want to have that one that contains in the URL something which is called nominatim. So this is a regular expression that I use here. Maybe not the best way how to do this, but let's just keep it for now. It's more or less about Cypress component testing and not testing. That request should be there, and I can answer it. So I say flush, and now I need to know what the OpenStreetMap or what the API returns. And in the case of a successful response, it would be an array that contains some elements. So as long as the array contains something, the address lookup will return a true. That's why I say, okay, yeah, return a true, something like this. Okay? So the HTTP request is answered. With the testbed, something we have to know, it would be answered synchronously. So we would have, when we really want to test it with a real world behavior, we would have to add some kind of asynchrony in there. But let's just leave that for now, because we have already asynchrony there in a second place. That's here the delay operator. So this operator will make sure that even if the request is answered synchronously, there will be an asynchronous task starting. Now we need to make sure, because otherwise we cannot continue, that this asynchronous task is executed. Now we don't have access to it, but we can use here, of course, the fake async. So we say yes, our test should be equipped with fake async, like this, and I want to run here a tick. And if I have executed the tick, I know that the asynchronous task has finished, the observable received its value, and now I can say you need to re-render the HTML, because otherwise let me quickly go back. Otherwise, this paragraph will not be rendered and we wouldn't see anything. So this is why we quite often see a tick, which is immediately followed by a fixture detect changes, as we see it here. And now, we finally reached the end. We can query for the message, and the way how I do this, just copy it. I say there should be something, which is the lookup result. And what I want to know is if, I say message native element as HTML paragraph element. And I want to say if the message has a text content to be, what should it be? Well, Proscia sent. This is the success message. Proscia sent. Now, of course, you should never run your test with a successful message in the beginning. You should always let it fail first so that you are aware, or that you really know, okay, the test is really testing what it should do, what it should actually test. So I'm more or less forcing here an error by using a typo. And then I just run chest like this. That's at least that of course you can also run it via the IDE. And we are getting here an error message telling us, look, there was a message, but you have obviously used the wrong letter. So I say, okay, yeah, that was on purpose. And now it is working. Okay, so this is now more or less the test how we usually would write these days. And I think it's clear, or that we see here all the 4 different reasons that I managed. They are all there. So first of all, the testbed the configuration of the testing module should be clear so far, that it can become a little bit more complicated. Of course, it also depends on your application. If you're not using standalone components or scams, and if you have instead Angular modules that contain or declare multiple components, it's much harder to find out the real dependencies. This was the first part. The asynchrony, we have also seen it here with the tick. So we have to be aware of the delay operator in our case. DOM interaction is more or less that part here, that we need to dispatch the input event because otherwise it will not work. And then we had the change detection, which runs in the beginning and also before we finally can do our request for the message DOM element. Yeah, and I mean, to be honest, this is a very easy example. I'm sure in your applications you have much more complicated components lying around. And if we say we have to come up with that amount of code, and there are quite some pitfalls in there that we have to be aware of, I don't want to know how it would look like, how a test would look like when a more complicated component is involved. And this is exactly what I meant. This is the reason why testing is so hard. Now, I want to show you something else. I don't want to hide this from you because there are some tools available that can make this kind of tests easier. There are 2 main libraries. There is Spectator from Nginx, and there is the testing library. So I have rewritten the same tests with these 2 libraries. They are already here. Maybe you have seen before in the test run that some further files were also executed. And here we have a test written with Spectator. So you see the code here is a little bit easier to read, also easier to write. For example, we have here a type-in element which replaces the need to dispatch the custom event. This is because Spectator is aware that this is quite a common case and we can just shorten it. So Spectator does this internally. Also, the way how we select our elements is much easier. We have here a by test ID, which more or less replaces the debug element, query by CSS, whatever. This is really short. Also, the way how you can configure the testing module is normally a little bit easier. I mean, you still have to define what should be mocked and what not. As I said before, this is something that can't be automized. And the change detection is also, I mean, we don't see here any fixture detect changes. This is also because Spectator takes care of that internally. The only thing that Spectator cannot do is to call or to trigger the asynchronous tasks. That's why we see here a tick. Well, and then we also have the testing library, and the testing library is here. It's even shorter, I would say, than the Spectator test. We have here a render function. The render function is more or less the testbed, configure testing module, create component, fixture detect changes. So it replaces all these three commands. We can also come up here with HTML, with static HTML code. So as long as a component is imported or is declared here that has the app request info as selector, it just works. Of course, I could also just pass here the type for my request info component. Both the ways are possible, but in the end, yeah, it's here again the same configuration of the testing module. But we see here an async function is an asynchronous function. We have again functions to find DOM elements via their test ID. We have helper functions that make it easier for us to interact with the elements. In this case, user event is far more superior because it is also dispatching the real events as they are done in the real browser, so even better than the one that we have seen before. And in the end, we have here also our expect. It also contains two additional fantastic features, I would say. First of all, we have here screen find by test ID. Please mind the find, because here I've used the get. The find means that internally it is waiting for the DOM element to appear. So even if there are asynchronous tasks running, it will trigger them. It will also trigger the change detection, and only then will this promise resolve, of course, when the value is there. But we don't need to write the tick and the detect changes here. And of course, we also don't, as you see, I'm not accessing here any DOM property. I just say there should be text content inside of this returned value, which should be processed. So this has nothing to do with the component test runner, but I just wanted to tell you there are options to make your life easier with the classic way of testing in Angular. Of course, this is something you also have to learn in addition. It's definitely worth it, but, and that's the core message here, component testing is even better. Before we do component testing, I want to rewrite the same test by using end-to-end tests. So for all of you who've never seen how Cypress works or how it looks, that's now for you. The other ones, you can of course stay, or you can just forward to the component test itself. So for Cypress, we need to start it first. When we want to run an end-to-end test, we need to have two things running. The first one is the application itself, and the second, of course, is our testing framework. We see that it's already configured, so I click here on end-to-end testing. I can select the browser, and then I can start with the actual test runner. Now we don't have any tests, but that's what we're going to change. So if we take a look at our application, what's going on? When we write an end-to-end test, we say, okay, I as a user, I'm opening my website or this application. I click on holidays. I click on the first Get a Brochure button that I find inside of my holiday card, and then I just type in something into the address. I click on Send, and that should be it. Let's see how this works in Cypress. So Cypress, new directory, end-to-end, and I say request info, CyTS. it should test the request info. So in Cypress, we need to open the page. We do this by visit and pass on an empty string. This should already be enough to do our first check if it's really working. So everything I need to do, I can go to my Cypress window and I click here on request info. It already shows me that this file exists. I click on it and we should see that Cypress ends with an error message because we didn't define the URL. So this is what I'm going to change now. So I say HTTP localhost 4200. Normally you would come up with you would put this value into the configuration, but let's leave it for now. You see here Cypress immediately is rerunning the test. We see here our application and we see this looks so far so good. The question of course now is how can we open now the holidays? And here again, I mean, we have here the possibility to use a selector. So it's telling us here, hey, look, this button has data test ID set. Maybe you want to use that one. This would be the command, scikit. I say yes, so cool, why not? I copy it to my clipboard. I'm going back to my code. I insert it. So this means Cypress is now selecting this DOM element and I want to click on it. Again, if I want to see the effect of this command, I just need to go back. Cypress is rerunning it and you see what's going on. Well, and now about clicking on the first get the brochure button. I use here the Chrome developer tools. So what I have to find, there should be a DOM element with the tag app holiday card, and inside of this DOM element there should be a link. It's not a button, it is a link. So I say here the first app holiday card, and from there go down in the DOM tree and find the link. So how do I do this? Well, in the same way I did it before. Instead of using data test ID, I say app holiday card. That's the tag name. I say I want to have the first one, and then go inside of it, go down and find me the A tag. This is not the best way on how to do it. You should have data test IDs in place and all that stuff. Yes, but for now, I just say I want to click on it. Let's go back. And we are on our request info component. And now we have to do the same things that our testbed-based tests have already done. I need to type in something into the input, which has the data test ID address. So I could say data test ID is address, or in Cypress I have also prepared something which is called a command. So there is the possibility to say I want to have a test ID based DOM element, so I don't have to write this all the time. So like this. What do I have to type in? Well, I have to type in some kind of address. So let's stick to Domgasse 5. And then I want to click on the button, obviously. Again with the test ID. This is button search. I click on it. And then in the end, once this is done, there should be a lookup result which appears. And that one should have a text. And in the best way, this text is brochure sent. No need to wait for asynchrony, no need to deal with change detection. Of course, it's running in the browser, we don't need to trigger it. We also don't have to care about DOM interaction because it's the real browser. And well, it is much easier in the end. So if I go back, the test is rerun. We can watch it, we see something. We see here the brochure sent is the right one. We can even go back in time. So if I'm unsure if something has not worked, I can just go back here in time, scrolling over the previous commands like this. This is just perfect. So if you see this for the first time, I think it's clear why many people just say, okay, I know this is maybe is not the best way how to do all my tests, but they are very good tests. I can cover the majority of my use cases, hopefully, And I don't write these kind of tests and never write any component tests anymore. Speaking of the disadvantages, I mean, if everything's so good, what's the problem? Well, the problem with end-to-end tests is always the same. They are very slow, and I would say even the larger problem is, the bigger problem is that you need to come up with the infrastructure. So you need to set up the front-end application. If you have a real end-to-end tests, then you also need to set up the backend. If you have microservices, good luck with that. We also need to set up databases. That's all not that easy, especially if you want to run these tests in a CI pipeline. Very hard to do. So you're more or less outsourcing the amount of work to your colleagues in the operations department. But in the end, or what we see in practice is that many companies say, look, the tests, they are just running too long, so we cannot afford to have too many end-to-end tests, and or it is just too hard to set them up, so please don't write end-to-end tests because we cannot provide you with the infrastructure. So this is the disadvantage of end-to-end tests. So component tests and end-to-end tests. We have seen with component tests we can isolate components, test them very fast, so the execution of the test is very fast, but we have to deal with some great obstacles, let's put it like this. On the other hand, we have seen end-to-end testing, very easy to write, but we cannot isolate parts of our application and we have to test everything always together. Now this is where Cypress Component testing enters the game, because they say, look, you don't need to deal with all these issues from your component tests, nevertheless, you can test your components as they are in Jest or in Karma, but with the commands of Cypress. And of course, all its advantages that it has. And the way how it works, you just need to activate it in Cypress starting from 10.5. And then you add a new file to your existing folder where your component lies and start writing that particular test. So I have here my request info folder. I create a new file and I call that one request info component, and now not spec.ts but sci.ts. This is the sign for Cypress to pick them up. I say should test request info component, and of course since this is now a component test, it still is based on Angular. This means we also need to come up with that testing module where we define all the dependencies. So this is not something that goes away. But the way how we set up this component works like this. So we have the command scimount. Here I can say I want to test the request info component, and of course then comes the testing module configuration, where we need to import now the dependencies as we have done in our component test. So I go to my component test, to my component spec, say yes, these are the 3 modules I need, and I just paste them into this file. And now I can already check if Cypress is picking up the test and if it is actually able to render it. So I go to Cypress, component testing this time, not end-to-end testing. It takes a while. I pick the browser that I want, the window opens, the component test is already shown. I click on it, and we see that the request info component is visible in our test runner. And now I just copy again the commands, but this time not from the component test, but from the end-to-end test. So if you remember, request info, where is it? Sci, that's the one. These 3 commands is what I require. Okay, and I add them here. Now that's not everything, except that I pasted it into the wrong place. Here is much better. No, I can now choose, because I can say, yes, I want to use the real HTTP client module, because maybe I really want to use the OpenStreetMap API, or I just want to use the tools that Cypress gives me, because we can also mock the network via Cypress as well. So if I go with the later option, I have to say, okay, I want to use the HTTP client module. So from the perspective of Angular, it is using the original one. It is really sending out the request. If I let this test run, we will see this. Of course, it takes a while, but the real request happens. So it says here process send. And I can, of course, now change that. I can now intercept my network by using Cypress functionalities. So the way how this works is that we say, well, intercept. I say in the same style as I did in my component test, there should be a URL where nomi natim happens. And then I'm returning a body. In my response, I'm returning a body that is just saying true. This will define this whole thing as a valid address. But if I want to test the opposite, namely that the address is not valid, I just leave an empty array. And now this test must fail because the message isn't process sent anymore, but address not found. Let's check it out. And we see it's really address not found. So again, if we take a look, we see it's kind of a hybrid thing. We still have all the options available to isolate parts of our application, define the mockings that we want, but we can use then afterwards the Cypress commands as they are. And asynchrony, change detection, everything's as with end-to-end tests. It's not a problem, it just works. Depending on the end-to-end testing framework you use, you have these timeouts, they're included, which you can also change. But this is definitely a way how writing component tests really makes fun. Well, and in the end, there might be a small issue with that test. You might say, hey, what's that? The icons are missing. Well, yes, of course you can add them. We can even do more with this test. First of all, we can say not about the icon, but maybe I want to use the real animations. Be careful with that. Animations in applications can also cause problems for end-to-end testing tools, but nevertheless, I mean, we can try it out. I can say, okay, I want to use the browser animations module. Now my test is even closer to the real thing. And when it comes to the location symbol or icon there is one trick that you can also apply always in component tests. You can just come up with a wrapper component. So in this case, you can say, okay, there is this wrapper component. It's a normal Angular component. So it's class wrapper component, and it has obviously the decorator of component. Where we say, yes, there should be a template. Inside of this template, I want to use my app request info. But that's not the only thing that I want to use. I also want to import the styles, the link tags that we usually only find in the indexed HTML and where the fonts, but also the icons are loaded. So this means I'm opening the indexed HTML, and there you see what I mean. These three tags there, they are also required, or not really required, but it just makes the test a little bit better. So I save it. It's a little bit more verbose now, but I can now say, instead of mounting the request info component, I'm mounting my wrapper component. And of course, I also need to declare that one now, because at the moment it's not a standalone component. So I can say declarations, wrapper component, like this, but that should be it. So if I go now back to Cypress, we see, of course, it was a little bit lazily loaded, but we see that the location icon here really is there. It's still address not found. Let me fix that. Address not found. This is the message we want to see. And it's there. And that's it. Okay, so this was the Cypress Component test runner. I hope you can agree that it is really much easier to write tests. Summarized again, it's not that it's just easier. We also have a real browser. We also see quite a lot. And of course, we can access everything from Cypress functionality, which is of course excellent. The question now is, are there any reasons why we don't want to use it? The component tester is in beta version, so it's in a very early stage. We don't have that much experience on a large scale. And nevertheless, I think it will be slower, but not that much slower that you say it's unacceptable. I mean, we have to, of course, end-to-end testing always has this reputation that they are much more slower than the other tests, but this doesn't hold with component tests anymore because there is no application that runs. We don't need to open a page, no navigation happens and all that stuff. This is all not happening in the component tests. So I would say I would expect them to be a little bit slower, but not in a way where I would say it's a problem. Speaking, I mean, what I would do is that first I take a bunch of my existing tests that I have already written, rewrite them in Cypress, and then just compare the times. Speaking of migrating them, what do you have to do? Do you have to rewrite everything? Not really everything. And the good thing is the testbed configuration still stays the same, so you can more or less copy and paste it. Of course, when you're using mocking, for example, in Jest, it has some good mocking capabilities. You can keep that code as well. What you have to change is the way how you interact with your components. There you just use the Cypress commands. So you don't have to throw away all of your code. Some code can still be reused. There is one area in testing where I would say you don't want to use Cypress for that, and that's of course when you have service-based tests where you don't do any DOM interaction. I think that's clear. So when you, for example, say you have an NGRX state and you only want to test the state itself with all its elements, only a bunch of services together, then I would say I would use Jest or Karma for that, because obviously as long as there is no visual feedback or DOM interaction, I don't see a reason why to use Cypress for that. Well, that's it. I hope you have liked my video. If you see any reasons why you shouldn't use Cypress Component Tester, please let me know. Add a comment. I would be very interested in hearing your opinions on that. Other than that, thanks again and see you soon in another video. Goodbye.